Hey guys, in this video we're going to be discussing how to use different theorems that we've learned to solve for certain problems. We're going to be using the theorems in this video are going to be the secant product theorem, the chord product theorem, as well as the secant tangent product theorem. So these three main theorems we're going to be using in this basis of this video. So we're going to be talking about these four problems over here. So some of these problems will include only a measurement, and we're going to have to use that measurement to find that angle and then solve it from there. So let's get straight into the first two problems. So this is using the secant tangent product theorem. So it's going to be something like this. I'm going to draw this out, write this out. So okay, have that out. We're going to write that out. It's going to look like this. So it's going to be 4x squared plus 4x minus 12. And then when you solve that out, you'll get x plus 6 and x minus 2. And you can only have positives, so your answer is 2 there. So this is basically the same thing. So we're going to skip that, skip this. We're going to go straight to number 4. So this is using an angle right here. So 60, this measurement 60. We don't have the line for this. But what we do have, and we do know, is that we know how to work with triangles, with special triangles. Made the video back before a little bit, and so therefore we can use some sort of triangle theorem to figure out what this line actually is. So this is 60. The central angle will also be 60 because of the central angle theorem, and that intercepted arc is the same as the central angle. So 60, this will have to be 60 as well. And since it shows here that the radius of the circle is 5, because any point from the center to the outside corner will always be the radius, and so the radius will be universally around the whole entire part of the circle. So this will be 5 and this will be 5, and therefore, and also realizing that this is a 60-60-60 triangle, which is an equilateral triangle, each side will be the same. So if one side is 5, then all the sides are 5. So this line will be 5. Then you can solve from there using the secant theorem. So that's going to be, let's see. So it's going to be x over x plus 5 equal to 5.5. over. Also important thing to realize is when you're using this measurement of the inside, you have to use the entirety until it hits the other side of the circle. So this is going to be 5 because it's also radius, so 10 15.5. right, then you solve from there. Let's quickly just calculate that out. So it's going to be 82.25 x squared plus 5x minus 82.25. And that's going to be your equation for that problem. Alright, let's move to the next one. So here it's a similar situation, just with a different angle in the middle, angle on the intercepted arc. So this will be 90, using the same theorem we talked about before. This radius will make these both sides 1, and since this is a 90, the other sides will have to be 45. And the reason that I know that is because this is a 45 special triangle, and that these sides are equal to x, and 90 will be equal to x root 2. So therefore we can plug the 1 into the x, and then it's root 2. So this side is root 2. Then we can solve this as usual. Bring this to the other side, that equals 1. So it's going to be 1 is equal to x over x plus 2. Boom, x squared plus x2 is equal to 3. X squared plus x2 minus 3 is equal to 0, and that's your equation. boom, 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 done. So let's go to the last one. So this one is actually a little trickier, but we'll go step by step on how to solve this one, and it should be easy after understanding how this works. So we get an angle of 120 as the intercepted arc, and we're trying to find this line right here. But how are we going to do that? We can still set up a triangle like we have with the other problems, but then this arc will be 120. And what can we do with that? There's no there's no special angle theorem where we have a 120 angle and you can find the other angles. So therefore, if we simply, knowing that this is 120, split that 120 in half so that each side will be 60, then we can use the 60, 30, 90 triangle theorem. This is the 90 because it's a linear pair, and it has to be because this is bisecting, that the other side is perpendicular, so these will both be 90 because this line is 180 degrees. So 60, 90, 30 triangle. This is a special triangle. Again, you have the radius, you know that these sides are both 4, and the 90 degree, the opposite side of a 90 degree is 2x. So 2x is equal to 4, x is equal to 2. So our x in this special angle will be 2 after knowing that this is 4 and just going backwards from that. There, nextly, 30, the angle of the special angle for the 30 angle degree, it will be 2, will just be x by itself, so that'll be 2, and then the 60 will be x root 3, so that'll be 2 root 3. That may seem a little confusing, so I'll draw it out in case you guys didn't understand that. So this is the 90, this is the 30, this is the 60. So the opposite of the 60 will be x root 3, opposite of 90 will be 2x, and opposite of 30 will simply be x. So that's what we just applied here, and we know that double 2, 3 will be 4, 3, so its entire line's length will be 4 root 3, and there we can solve for our equation. So it's going to be, also make sure to always draw that out. So that's gonna be, so it's 8, 16, 8, 16. Is equal to x plus 4 root 3. And then just put them on the same side. And boom, guys, that is your final equation, and that is how you solve these types of problems. If you guys enjoyed the video, please make sure to smash the like button and subscribe. Just leave a comment down below. We're going to be going through these next ones in our next video. See you guys.